Good morning. We're glad that you are here to join us for our next installment of our deeper dive into the district's mission, flood protection this week. A reminder that all of our participants are on mute and will be on mute throughout the presentation. We do encourage you to enter in questions as they come to your mind or as you think of them. We will have a question and answer session at the very end of the presentation. And if we do not get to your question due to time constraints, then we will email you directly the response to your question about flood protection. Today, we are super excited to have Matt Forhan, one of our engineers in the Bureau of Operations and Maintenance, and he is going to give us a lot more information about flood protection and the way that the district accomplishes this mission. Just a reminder for all of you who may not have tuned into our previous webinars, we are the St. Johns River Water Management District, and we cover all or portions of 18 counties. It's the entire watershed of the St. Johns River and then some of our coastal rivers as well. And it is our mission to ensure that we have water supply and appropriate water for all of our natural systems and for the people of our district. And so you will also hear about how our four core missions, how water supply, flood protection, water quality, and natural systems are highly linked, especially when we're thinking about the fact that all of our waters in Florida are interconnected, whether we're thinking about the surface water or our aquifer systems. And so if you are interested in any of our other core missions besides flood protection, we did have webinars on those, and those were recorded and are posted onto our website and on our YouTube channel. If you're interested in finding those recorded webinars, please go to our website, www.sjrwmd.com/education, and you'll be able to find the link for those. Again, today we are going to be talking about flood protection. And these are just some great images of some of the methods that we are utilizing for flood protection, whether that be using those natural systems for flooding or through some of our control structures. So with that, Matt, I really appreciate you giving us this deeper dive into flood protection.
Well, thanks for having me. Again, guys, my name is Matt Forhan, and first I'm going to take you through an overview of our flood control system. Then we'll get into some detail about what we do in flood control operations. I'll show you some of the internet products that we publish on our website. And lastly, we'll field any questions that you might have. So this is an overall view of the major flood control structures that we operate. These are broken up into two groups. The first group is in the upper St. Johns River Basin. As you may know, the St. Johns River flows northward, discharging eventually into the Atlantic Ocean near Jacksonville, Florida. The upper part of the river is the southernmost region. Similarly, our second group of structures is along the upper Ocklawaha River Basin. The Ocklawaha River also flows northward, discharging into the St. Johns River. So let's take a peek at where some of these larger structures are and what they look like. The first structure I'm going to show you is Moss Bluff. Moss Bluff is shown in the center of your screen. It is southeast of Ocala along the Ocklawaha River. This is what that structure actually looks like. Here we're discharging about 2,000 cubic feet per second. This is the largest and only federal structure that we operate along the Ocklawaha River. And it is used to control the level of Lake Griffin, but it also passes through all flows that come from Lakes Apopka, Eustis, Harris, and Dora. The next structure we're going to take a peek at is S161A. This is in the bottom right of that map. S161A is south of US 192 and west of Melbourne. Here's the structure. On the top of the screen, you're looking at the Jane Green detention area. And this structure is discharging in this picture about 5,000 to 6,000 cubic feet per second. This is such a big discharge that we actually have what we call a trigger to close the structure. So this structure and one other one that's just south of it are always left open. Unless the St. Johns River at US 192 gets to a certain elevation, when it reaches that elevation, we actually close these structures to prevent flooding of that critical evacuation route. This is unusual because every other structure that we operate is typically closed until the water levels reach a certain elevation, and then we open them. The last structure we're going to take a peek at is S157, again on the bottom right of your screen. S157 is between Melbourne and Vero Beach, east of Interstate 95, along the C54 Canal.
Let's talk about country club members. So if you're a member of a country club, then you may assume that you have to pay some.
Oh, looks like we're getting some feedback on the line. Bear with me 1 second, guys.
Provided for you, you do have rights as a member of that club.
Give me 1 second. Sorry about that.
Mute this.
All right. Appreciate your patience, guys. S157. This picture was taken in 2004, a year in which we saw multiple tropical systems pass through the area. This is a rarely used emergency flow outlet. It is used to control flooding in the St. John's water management area, also known as Stick Marsh. I love to use this picture because it's a great snapshot of what we do in flood control. It is a constant balancing act between the forces of nature, in where we're constantly monitoring water levels and making appropriate discharges. So with that, let's get into what the flood control process really is. The foundation of everything we do is data. We rely heavily on data coming in. We take that information, we synthesize it, we make decisions on what we're going to do, and then we take action. This is an iterative process. We are constantly doing this. Every single day of the year, we are looking at this information and making decisions. During the wetter parts of the year, we may do this process 2, 3, 4, 5 times a day. So what kind of information do we have coming in? Well, first we collect a bunch of internal data. This includes water levels and rainfall information. Water levels are important not just because they tell us what the levels of the lake are, but also because we need to know what the water levels are just upstream and just downstream of our structures. We call this the headwater and the tailwater levels. We use these two levels to calculate flow through the structures. So it's very important that we know what they are. You might be wondering, what's the difference between primary and redundant? Basically, we rely so heavily on this water level information that at each of these sites, we have 2 water level sensors. And we do this so that if one of them fails or has some sort of issue, we can rely on the other one for our flood control operations. We also rely on lock tender readings in the upper Ocklawaha River Basin. We get these readings that provide us the dam's headwater, tailwater, and rainfall information. We also use the U.S. Geologic Survey information at a number of our sites, the 2 most important of which are at the Palatka River as it discharges into Lake Harris, and in the Blue Cypress Creek as it discharges into Blue Cypress Lake. Feedback again, sorry about that. All right, these 2 USGS sites are important to us because they flow into our system, and these discharges can be quite significant at times. And then lastly, obviously, we rely on weather data. So what do we do with this information? Well, first we're looking at lake levels because that's what we control. Are they going up? Are they going down? How quickly are they doing this? And then we also have to take into account wind effects. At most of our lakes, this isn't really an issue, but some of them it is. For instance, Lake Apopka. This lake is huge. It's 30,000 acres, but it's very, very shallow, which means it's highly susceptible to wind effects. What this means is that when you've got a sensor on one side of the lake, if the wind is blowing toward your sensor, the lake is stacking up against that sensor and it looks like it's higher than it really is. But if the wind is blowing the other direction, it pulls water away from your sensor. So when you're looking at it, you might think the lake is lower than it really is. So we have to interpret the information that we're getting in the context of what those winds actually are. We also look at regulation levels. What are they currently and what will they be in the near future? We have to take into account construction activities. We constantly maintain our structures, and sometimes this means we have to close them or limit them for repair activities. There are also periodic drawdowns, just upstream or downstream of our structures. Rainfall expectations. What's coming at us in the next day? What are we looking at in the next week? So inflows and outflows, there are two parts to this. First, we have to balance what's coming in and what's going out. When I say this, let's take a look at Lake Griffin. You may have 500 cubic feet per second coming into the lake, but if the lake itself is also high, that means we might have to discharge 600, 800, or 1,000 cubic feet per second out of Lake Griffin through Moss Bluff in order to control that lake. We also have to take into account flows that come to us from other agencies. Some of these agencies that we work with include the St. John's Improvement District, the South Florida Water Management District, SunAg, and Lake County Water Authority. So what kind of actions do we take? Well, first, we open, close, or leave gates alone. And we have to take into account, obviously, how much, not just how much do we open them, but how fast can we open them. We have limitations at some of our structures that we call a maximum allowable gate opening. What this means is that under certain headwater and tailwater conditions, there's a limitation to how much you can open your structure beyond which you can actually cause damage to it. We also have to take into account environmental effects upstream and downstream of our structures. We also provide courtesy warnings for boaters and businesses, 3 examples of which are shown here. 2 of them, the Bonfire Village and Haynes Creek Village, these are just downstream of the Borough Lock and Dam along the Haynes Creek. And these groups have boats along the creek that are housed in boat lifts that are up, they're not boat lifts, they're basically free floating and they're covered with a gazebo style roof. With that, the issue becomes when you discharge beyond a certain level, the water comes up and it can actually pin those boats underneath their roofs. So we provide a courtesy warning for them anytime we make discharges above 500 cubic feet per second through the Burrell Spillway. Similarly, we notify the Rodman Reservoir, which is downstream of Moss Bluff, anytime that we make a discharge above 500 cubic feet per second through Moss Bluff. Another thing we do is we create internet products, and let's take a peek at what some of those look like. So this is a simulated work product. This is just generic what could happen, and what you're looking at is what we call the side view of the system. You're going to look at on the top part of the screen levels of the lake over time. Along the left-hand axis, you've got stage in feet. The middle part is going to show you rainfall, and the bottom part is going to show you discharges that we make through the structure used to control that lake. On the bottom part of your screen, you can see that axis is time. We are looking at about a year's worth of data here. The first line you're going to look at is what we call the regulation schedule. The regulation schedule is basically the target that we try to maintain our lakes at any given time. Generally speaking, when water levels are above the regulation schedule, we make discharges. And when they fall below the regulation schedule, we stop. You'll notice that the regulation schedule during the summer is lower. The reason for this is that we need additional capacity for flood storage during the summer. During the winter, it's higher because we don't need this additional flood storage capacity, and that higher level also is good for recreational activities. So let's take a couple steps through the simulation. The lake starts in October, just above regulation. The regulation schedule jumps up over it as it climbs into its winter level, and the lake continues to peter up, up, up until it finally exceeds that regulation schedule. Once it exceeds it, you can see on the bottom, in February, we make our discharge and bring the lake back down to regulation. The lake stays under regulation until we get into April, where the regulation schedule falls below the level of the lake. You might notice, okay, you're sitting here in May, your level of your lake is higher than the regulation schedule, but why aren't you making any discharges? The reason for that is that we're looking at the forecast. We can see that there's not much rain coming, and we rationalize that if we let the lake sit, evaporation will bring the level of the lake down to the regulation schedule, which is what happened. So the next part of the simulation is summertime. You get a bunch of rain, water levels go up, we make discharges, they go down, and onward and forward until you get to the end of September. You'll notice the level of the lake is still above the regulation schedule, but we've stopped making discharges. Again, the question is why? The reason for this is that we're looking at the forecast. We're not seeing much in the way of rain, but we're also looking at that regulation schedule in October. It's going to start coming up very steeply, and so we rationalize that we can let the regulation schedule overtake the level of the lake. Now let's look at what some of the real products that we create are. The first one is the water levels page. This is very similar to the simulation we just went through. In the top here, we're looking at the lake levels for lakes Harris, Dora, and Eustis in the Upper Ocklawaha River Basin. You'll notice that generally lakes Harris and Eustis are maintained at or near the regulation schedule. Lake Dora in the summer is frequently above its regulation schedule. And the question is why? Well, all water leaving Lake Dora must go through the Dora Canal to reach Lake Eustis. The Dora Canal is extremely beautiful, but absolutely terrible for water conveyance. So it is very typical to see Dora's water levels increase above the regulation schedule and stay there throughout the summertime before finally coming back down and matching its other sister lakes. So let's go through the other type of product that we put out there on the web for you. It's called the flow system. This can look very busy, especially if you've never seen it before. But basically, this is a cartoon rendition of the top-down view of what our system is. It provides you information for one particular moment in time, a snapshot of where you are on a particular day. So if we're going to zoom in on the middle of the screen here, you'll look to see right in the center, back to the data. There's our primary and redundant water levels for Lake Eustis, what the regulation schedule is at that particular time, and then where we sit relative to that regulation schedule. Here we're about a ½ inch above that. You'll also notice around the picture we've got these structures. You can see what the structure is doing at a particular moment in time. In this moment in time, we had gates 1 and 6 at the Burl Dam open 1.1 feet, and we were discharging about 200 cubic feet per second out. So we're going to look at that same product now for the upper St. Johns River Basin. Again, it's very busy if you've never seen it before, and we're just going to zoom in on the center here. This is the St. Johns Water Management Area, also known as Stick Marsh. Again, in the center of the screen, we focus on those water levels, our primary and redundant ones, and then where we sit relative to the regulation schedule. And then around the perimeter, you can see various flood control structures, and then what their flows and levels are at a particular time. So with this focus on data, a question I sometimes get is, what happens if there is no data? What if there's an act of God and you lose everything? Well, we have to know the water levels, as I said earlier, not just to know where the lake is, but to calculate the flows that we're actually discharging downstream. So what we have are these staff gauges, we call them. These are basically measuring tools that help us to determine what the levels are. And we send observers out, if we need to read off of these and report back to us so that we can use this information in our calculations. We actually have a project ongoing now where we are changing some of our staff gauges from this older style where you've got you know, a little bit of confusion. Which staff gauge do you read? Do you take the one that's newer? It looks like it needs to be cleaned up a little bit. Now we're upgrading them so that they are all highly legible, high contrast, very easy to read. So where do you go to actually look at some of these internet products? Everything starts with our public website, SJRWMD.com. The first thing you're going to do is on the top right part of your screen, there's a menu button. You'll click that. This creates a drop-down bar here. And that drop-down bar on the right-hand side, you'll click Data and Tools. Then you'll click Hydrologic Conditions. And lastly, Controlled Water Level Reports. This will show you a series of hyperlinks. Each one of these opens up a single PDF file. These PDF files update every day exactly at noon. And the only trick to this sometimes is we know that some browsers store older files in what's called the cache. With that, in layman's terms, if you open up the file and it looks older than a day, then what you need to do is go to the top of your browser and click the refresh button. That will solve the problem. So with that said, we're going to get into the Q&A session.
Thank you so much, Matt, for that wonderful overview of all of the structures that you're controlling and all of the data that you're integrating into those controls. The first question that we have that came in is one about how does your work change because of hurricane season? You touched on it a little bit with the regulation effort or the regulation levels changing, but how do things in flood protection change with the impending hurricane season that we're in?
So throughout the year, every day we're checking water levels. As we get into the more active season, I'm checking them sometimes 2 or 3 times a day. We also start to meet as a team. We have a whole flood control team. I'm just one member of that. And we'll meet together twice a week or more frequently if we have a tropical event coming. When we start to talk about a tropical event, we actually make sure that staff are available before and after any major storm. During a major storm, gates are set in place and they're left alone. We wait until the storm has passed, and after the storm has passed, field staff inspect the entire flood control system. While they're doing that, our flood control group goes through the iterative process I talked about earlier as we make changes in response to the water levels.
So are you having to actually go out and manually open and close these gates, or how is that working?
So typically at almost all of our structures, I can remotely operate, open and close these structures from a computer or my phone. Sometimes we have to undergo repairs. Sometimes you've got minor glitches in the system, but typically that's how it's done. If for whatever reason I were to lose connection or there was some issue in the communication process, we call our staff and they can go out and make manual gate changes.
Okay. Who is it that is setting the regulation schedules for the lakes and district properties?
So we have 2 different sets of regulation schedules. The vast majority of these are set by the U.S. Army Corps of Engineers. Everything that you see in the upper St. Johns River Basin, those regulation schedules are set by the U.S. Army Corps of Engineers. It gets a little different when we go to the upper Ocklawaha River Basin. For Lake Griffin, that is again controlled by the Corps of Engineers. But for Lakes Harris, Eustis, Dora, and Apopka, those regulation schedules are actually set by the district.
Okay. You had also mentioned when you're deciding how much to open gates and that type of schedule, that you look at the environmental impacts. Can you talk a little bit about the effect of scouring at the dams and some of those environmental considerations that you undertake when you're deciding what you need to do?
Yeah, so again, we typically try to moderate the extent to which we open and close our gates. We, if at all possible, avoid going what I've heard to refer to as full blast, full open to full close. So basically, we are balancing where we're at now and what kind of rainfall we've got in the future. So sometimes we have to make more aggressive discharges, and sometimes we look at the rainfall and say it's not going to be a whole lot. There's no tropical systems coming. We could take a longer period of time to spread this out. So again, we basically try to moderate what we do to open and close it, but sometimes we have to make those more aggressive discharges to prevent flooding.
So with the discussion about flood protection, what role does the district have in local flooding that individuals might see?
So the flood control group itself has absolutely no role in local flooding. I know that the district works with some local entities for some cost share projects. This totally depends where you're at. This is a little bit outside of my scope of expertise, but generally local flooding is up to the local governments. They maintain your smaller culverts. They maintain your local retention ponds, things of that nature would be a local government question.
We also had a question that came in about data for Sawgrass Lakes Water Management District or Water Management Area, and they were curious if there was a way to access that data, as it isn't available where they accessed it previously.
Yes, there is. This takes just a moment. Let me actually, I'm still presenting. I can do this. It starts in the same place, our webpage, SJRWMD.com. You'll go to the menu, data and tools, same way you were going before. You'll go into hydrologic conditions, and then there's a on the middle right where it says hydrologic data search tool. This is going to open up all of the sensors that we publish on our website across the district. So for Sawgrass Lakes, you're going to come down here and we are going to look in Brevard County, and we're going to look at water level. And Sawgrass Lakes, for those of you who may not know, is actually down in this location west of Palm Bay. And basically what you can do is you can zoom in and click on these green dots, and they will tell you what we're looking at. In this case, Sawgrass Lake WMA South Pump Station water level. And you can access the information that way.
Thank you so much. One more question just came in of, do you use models of the control structure height versus control structure discharge rates to avoid potentials of flooding residential areas? How do those balance?
So our mission is to control flooding upstream of our structures. As far as using modeling, when the Army Corps of Engineers built these structures, they modeled out a variety of situations, and they took into, and they gave us these curves that tell us when your headwater is X and your tailwater is Y and your gate opening is Z, you've got this amount of flow going through your system. So that tells us, that helps us to determine what the flow is, but they also modeled out, and we have in our spreadsheets that we use at certain discharges, how long is it going to take to bring the lake from where it is right now until it gets down to the regulation schedule.
Thank you. Yeah, that is very helpful. And I do want to thank you so much, Matt, for this great presentation. We really appreciate the time it took to go into all of this information and hearing directly from you about how the district is working to help with flood protection. So thank you very much. I would like to launch one last poll to find out and to get input on future topics for webinars. So please select the topic. Those of you who are still in the audience, what topic would you like to hear in the future? And Matt, thank you so much. We were able to get to all of the questions that came in, so I appreciate your time today. And thank you all so much. Thank you all for your attention. And again, this will be recorded and available on our website. Please check that website, SJRWMD.com, for further webinars and to sign up for those. And thank you all so much.